Okay, so we just left off in part 1 solving for x3, and we're going to continue on in part 2 by solving for m4, and we're moving on to the filter. So let's do a solid balance at the filter. So at the filter we have x3, m3 entering, and then we have 0.75 m4 leaving for solids. And we know x3 and m3, so then m4 is equal to, let's see, 0.2175. M3 is 400 over 0.75. So M4 is equal to 116 kilograms. Now let's do an overall balance at the filter. So overall at the filter we have M3 is equal to M4 plus M5. So then M5 must be equal to M3, which is 400, minus M4, which is 116. So M5 is equal to 284. That's kilograms. Now we are going to move on to do a oil and hexane balance simultaneously at the filter. So at the filter, we have an oil balance. It looks like this. So we have Y3 M3 is equal to Y4 M4 plus X5 M5. And when we put what we know into that, we end up getting 0.0325. 400 is equal to 116 Y4 plus 284 X5 is equal to 13. And that's just 0.0325 times 400. So that is our first equation for this balance. Now for hexane, we have 1 minus Y3 minus X3 times M3 is equal to 1 minus Y4 minus 0.75 times M4 plus 1 minus X5 M5. Now let's simplify that equation out, and we end up getting that 300 is equal to 0.25 minus Y4 times 116 plus 1 minus X5 times 284. Now I'm gonna skip some steps, just algebra, similar to what you did on the first test, using these two equations to solve for x5 and y4, your two unknowns. And you end up getting that y4 is equal to 0.0104 and x5 is equal to 0.0415. Now what we're going to do is a hexane balance at the evaporator. And what that hexane balance at the evaporator is going to look like is 1 minus x5 times m5 is equal to m7. And we know x5, we know m5. So that leaves us with m7 is equal to 1 minus 0.0415 times 284, which is 272.2 kilograms, and that is M7. Now, our next equation is going to be an oil balance at the evaporator. And that looks like M6 is equal to x5 times m5. And that is 0.0415 times m5, which is 284. And that is equal to 11.786 kilograms. And that is M6. And now our final unknown. We're going to do an overall system balance. And the overall system balance is going to look like M8 plus M1 is equal to M4 plus M6. And solving for our final unknown, which is M8, we get 116 plus 11.786 minus 100 is equal to 27.786. And that is M8. Now, part B. Part B asks us to calculate the yield of bean oil product, the required fresh hexane feed, and the recycled to fresh feed ratio. Okay, so let's start with the yield of bean oil product. So the yield is going to be equal to M6, which is the final product, over the amount of beans fed. So that's 100 kilograms beans fed. And M6 is 11.786 kilograms. We're dividing that by 100. And we get that the yield is 0.11786 kilograms of oil per kilogram beans fed. And then next we want the required fresh hexane feed. So fresh hexane required. The fresh hexane required is going to be equal to M8, which is the amount of fresh hexane fed, over 100. So that's 27.8 kilograms of hexane per 100 kilograms feed, or beans feed beans. And that gives us 0.278 kilograms of hexane required per kilograms of beans. And then lastly, we want the recycled to fresh feed ratio. And the recycle ratio for this process is going to be equal to M5 over M1. No, it's not. Sorry, I take that back. It's equal to M7 over M8. I don't know why I wrote that down. M7 over M8. And so M7 is 272.2 kilograms. And M8 we know is 27.786 kilograms. And that gives us 9.8 kilograms of hexane recycled, not required. Per kilogram of hexane.